So we've got a second order differential equation here. Y double prime equals 3x cubed square root of. And the first derivative at 0 is 1. And the value of our solution at 0 is also 1. So interesting boundaries and conditions there for us to think about. Now our goal is to find this function as a function of x. That's what we're looking for. Okay, now this kind of problem for differential equations here, the best way to start with this is to integrate both sides with regards to x. So let's do that. So y double prime dx equals the integral of square root of 3x cubed dx. Okay, now to integrate this straight off, I like to break that down a little bit. So I like to have it in terms of indices. So 3x cubed. So what I can do is I can break the coefficient and the x term apart. So I've got square root of 3 multiplied by the square root of x cubed. And then this term here is what I want to simplify off even more. So I've now got square root of 3 and then x cubed. So 3 will be in my numerator. And because it's square root, I've got a 2 in my denominator. So that is the same as that. So I'm just going to rewrite my integral in terms of that. So y double prime dx equals the integral of x to the 3 over 2 dx. And then I'm going to put square root of 3 out front. So I'm just going to give myself a little bit of room there. So that's a constant multiple, so that can stay there. Okay, so now I'm quite straightforward now to do my integration. So this is just going to give me y prime. I'm going to write that as a function of x and without a constant of integration, because I'm going to do that on this side. Now this side I've got the square root of 3 and then the integral of x to the 3 over 2, well that's simple power rule. So now raise the power by 1, so then that's going to be 5 over 2 and then divide by the new power. So now we're going to divide by 5 over 2, which basically just means multiplying this by 2 over 5. So that's my result there, and with my plus c, which is my constant. Okay, now I've got some conditions here. Y prime of 0 equals 1. So let's write that there. So that equals 1. So here I've got y prime of 0. So wherever I see an x, I'll plug in a 0. So that equals 1, which equals 2 root 3 over 5 times 0 to the 5 over 2 plus c. Okay, now this is just going to disappear and become 0. So that's all going to cancel out. So I'm left now with c equals 1. So that's my first constant already taken care of. So now I can rewrite my result with my c at value 1. So now I've got y prime of x equals 2 root 3 over 5 times x to the 5 over 2 plus 1. Okay, so that's my first bit taken care of with this condition. Now we need to integrate again, so let's go for that. And then we're going to get our y of x, which is our goal, and then integrate this again with regards to x. Okay, now we don't have to work out what this is in terms of indices. We've already got this now in our integrand. And here we're just going to have, by the fundamental theorem of calculus, is kind of similar to that. We're going to have y of x. So y of x, and then here, simplify off this integral. I can take this constant out front, so 2 root 3 over 5 multiplied by the integral of x to the 5 over 2 plus 1 dx. Okay, right, let's do the integral. So then y of x equals 2 root 3 over 5. Now here we've got a simple power rule again. So now we're multiplying this by x raised to 5 over 2 plus 1, which is 7 over 2. And then divide by the new power. So all this term will now be multiplied by 2 over 7. And then plus 1, the integral of that with regards to x is just x. Okay, now we're going to need a new constant of integration. So now I'm going to add on this time, I'm going to call this one d. Okay, now we've got this boundary condition here, y of 0 equals 1. So now I'm going to bring this up to the top, and then we're going to use this condition here and then try and put together our final answer. Okay, so here's our solution to our integration. So y of x is this, so we can tidy up this constant here, and then what we want to do now is find that y of 0 equals 1. So we're going to set all this to 1, and where we see an x we're going to plug in a 0. So now we've got y of 0 equals, right, let's tidy this up. 2 times 2 is 4 times square root of 3, and then 7 5's 35. So that's our constant taken care of. Now when we see an x we plug in a 0. That's what we need to do here. So now we've got 0 to the 7 over 2 plus 0 plus d. And that all equals 1, which is our condition. Okay, so now if we take care of this, where x is 0, we're going to find that our d is equal to 1, because these are all going to disappear, and then we're just going to be left with d equals 1. So now we can now write our y of x as 4 root 3 over 35. So now we're going to write these two terms in here, x to the 7 over 2 plus x, and then plus d, which is 1. Okay, now what we can do here now, we just put this back into terms of our square root. So now y of x equals 4 root 3 over 35. Now let's get a square root term here. So if that's a square root, we want x to the 7 inside the radical, and then close that off, and then add x and add 1. Okay, that is our solution to our original problem, y double prime equals the square root of 3x cubed. Okay.